welcome to the first video where we're looking at probability. So the first question we ask ourselves is, well, what is it? Well, probability is a measure of how likely something is going to happen. So let's have a little look at the vocabulary and the stuff that we use. So there's just a definition of probability again. It's a measure of how likely something's going to happen. And we're going to look at how likely one result is when we do something like roll a dice or toss a coin or take a card from a pack. Now, one of those results that can happen, that's referred to as an outcome. Now, if you have one outcome or more than one outcome, then we can call that an event. So we'll come across these two words, outcome and event, quite a lot in the study of probability. And it just means something that is going to happen, a result, in other words. So if you toss a coin, what are the outcomes? What can happen? Well, there's only two. There's a head or a tail. And if you roll a standard six-sided dice, then the outcomes there are 1, 2, 3, 4, 5 or 6. Now if we toss a fair coin and we want to know the probability of getting a head, we don't like writing too much in maths, so we shorten that probability of getting a head to just that. Nice and easy. P for probability, H for head, and notice the brackets. And we can express probability as a number. Now this could be in any one of four ways: fraction, decimal, percent, or ratio. We're probably not going to come across ratio very often at all. Percent, not often much, but fractions and decimals, we'll come across those quite a lot. Now, let's have a look how we actually calculate this probability then. So if we toss a fair, unbiased coin, what's the probability of getting a tail? Well, we actually have a definition here, and the probability of getting a tail is defined to be the number of ways of getting a tail divided by the number of all possible outcomes. So it sounds a bit complicated, but it's actually quite straightforward. Let's look at that up there. So how many ways are there of getting a tail? Well, there's only one way, and we get a tail. And how many possible outcomes are there? Well, there's two, head or tail. So we say the probability of getting a tail is 1 out of 2, or 1/2. And we could write that as decimal, 0.5, or percentage, 50%. Okay, so let's look at another probability. If we roll a fair unbiased dice, what's the probability of getting a 6? Well, it's a similar calculation. The probability of getting a 6 is the number of ways of getting a 6 divided by the number of all possible outcomes. So let's just shift that up there. How many ways are there of getting a 6? Well, there's only one. And what are the possible outcomes? Well, the possible outcomes are 1, 2, 3, 4, 5, or 6. So that means the probability of getting a 6 is 1 out of 6, or 1/6. And again, we could write that as a decimal, a percent, or even a ratio. But fractions work best in this case, so we leave it as a fraction. And remember, we don't really use ratio much at all. Okay, now if we roll a fair unbiased dice once, what's the probability of getting an odd number? Let's get the probability of that. Well, the probability of getting an odd number is the number of ways of getting an odd number divided by the number of all possible outcomes. Let's just shift that up there. How many ways are there of getting an odd number? Oh, there's 3 ways, because we could have 1, 3, or 5. And how many possible outcomes are there? Yep, there's 6. So the probability of getting an odd number is 3 out of 6. Now we could cancel that down. 3/6 is the same as a half, but we don't have to. We're not necessarily going to get any extra marks of doing that. And in some cases, when we're using tree diagrams, it's better to not cancel down. So we don't always have to cancel fractions. So let's get a bit mathematical about it. For a possible outcome A, we can write the probability of A happening is the number of ways of getting A divided by the number of all possible outcomes. And that's the kind of definition you'll see on websites and textbooks. And that number can be written as a fraction, decimal, percent, or ratio. Okay, so let's have a look. What size of numbers can we get for probability? So let's think of a real life example. What's the probability of it going dark tonight? Well, it's definitely going to go dark tonight. So we say in maths that it is certain. And if something is certain, then the probability is 100%. Or we could also say the probability is 1. Okay, let's have a look at something else. What's the probability of me eating the moon tonight? Now, I do like my food, and I particularly like cheese, but I'm afraid it's definite that I cannot eat the moon. So we say in maths that is impossible. And so if we want to put a number onto that probability, we'd say it's 0% or just 0. So let's have a look what we've got. We've got the full range of numbers that we use in probability in those last two examples. The highest value we can have for a probability is 100% or 1, and the lowest value we can have is 0% or 0. So let's have a look at those on a number line. So here is our number line. We notice that one end is 0 or 0%, and at the other end is 1 or 100%. At the 0 end we say things are impossible, and at the end we've got 1 or 100%, then that's certain. Now every probability must lie between 0 and 1, or 0% and 100%. Right in the middle we've got an even chance, which could be 0.5, we could also call that 50% or a half. To the left of even chance things are called unlikely. To the right of an even chance we say they are likely. And things get more unlikely as you get towards 0 and more likely as you get towards 1 on the other end. Okay, so let's have a look at some exam questions based on what we've learned. That's a bit bright, isn't it? So we've got Karen has got 12 cards. She's got 4 yellow, 4 red, 4 blue. The 4 yellow cards are numbered 1, 2, 3, 4, as are the red and the blue. 12 cards are all put in a bag and one card is drawn out at random. Write down all the possible outcomes. And I've done the first one for us, yellow one. Well, we could have a yellow card with 2 on it. We could have a yellow card with 3 on it, and a yellow card with 4 on it. Notice we've used a systematic approach, not just randomly writing stuff down. We could have a red card with 1 on it, a red card with 2, and you get the idea then. And there are all the possible outcomes. Okay, and there's 2 marks for that in the exam. It's quite nice, isn't it? Let's have a look at part B. It says, in a game, a player selects a card at random from the bag, and the player wins a prize if the selected card is a red card with an even number on it. What's the probability the player wins a prize? So I've just put back all those outcomes at the top there. Now, of those outcomes, which ones are winners? Well, it's got to be a red card with an even number on it, and that's what we'll use to calculate the probability of winning. So the winners, red and even, so those 2 there, red and 2, red and 4. So there are 2 ways of winning out of how many possible outcomes? And if you count those out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2 twelfths. Now we could cancel that down, although we don't get any extra marks for it. We could cancel that down to 1/6. Okay, so that's how we calculate a probability. This one is all about using words rather than numbers. Let's have a look at A. It is something the sun will set tonight. No, certain. We came across that one, didn't we? With the going dark. B. It is something that I'll get a tail when a fair coin is tossed. Well, we also covered that one. We had a probability of a half, which was an even chance. It is something that I score a total of 1 when 2 dice are thrown. Now, if we throw 2 dice, the lowest score we can get on each individual dice is a 1. So it would be a total of 2. So we can't get a total of 1. So that's impossible. And if you buy 1 ticket in a raffle where there are 1,000 sold, it's unlikely that you will win the top prize. It's not impossible, it's just unlikely. Okay, let's have a look at this one. More stuff with cards. And we've got to work out the probability here and put letters on that number line to show that probability. So A is the probability that the chosen card has the number 6 on it. How many got number 6 on them? There's 1, 2, 3, 4, 5. So that's 5 out of 10 cards have got a 6. So that's 0.5. So that's the bang in the middle. That's where we put A. B is the probability the chosen card has a number less than 8. Okay, let's have a look. How many have got less than 8? 4, 5, 6, 7, 8 of them. So it's 8 out of 10. Now 8 out of 10 is 0.8. So on our line, 0's on the left, 1's on the right, 0.5 in the middle. So 0.8 will be about there. And let's have a look at the last one. C is the probability the chosen card has a number more than 5. Well, if you look, all of them have a number more than 5. So it's 10 out of 10 cards have a number more than 5. So the probability is 1. It's a certain event. And there we put C just there. Okay. So that's that. We've introduced probability. We've had a go at some questions. Now, over to you to have a go on the exercise and I'll speak to you in the next video. Thank you very much. Bye for now.